Hi, my name is Sean Zong, and this is my Physics 2212 Lab 4 report on bar magnets. So before we get into this presentation, I'll just cover what we will be going through. So firstly, I'll go over the introduction, where I discuss the purpose and fundamentals of this lab. Secondly, the procedure, where I talk about the experimental setup and results. Third, the coding section, where I talk about the experimental versus computational models and how they performed. And then fourth, I'll answer the questions of what if and why. So the purpose of this experiment is to measure the magnetic field of a bar magnet at different distances and compare these observed values versus predicted values per the PHYS law. To spoil the results ahead of time, the value for n that we get in our linearized equation is negative 3.331, and then the magnetic dipole moment of the bar magnet is 1.57 amps times meters squared. So the fundamental principles guiding this experiment are firstly the Biot-Savart law, which is that the magnetic field at an observation point resulting from a current element is equal to that equation shown below. The magnetic field of a dipole is also a fundamental principle, and that is it acts very similarly to that of an electric dipole, actually, that we've seen earlier in this course. And that field is also given in that equation right beneath as well. And then also the magnetic field distance dependence. These equations were given to us in the lab and states that the magnitude of a magnetic field from a bar magnet decreases with distance. We have that magnitude equation right here, and then to the right is the linearized version where we took the natural log of both terms. So for the experimental setup, firstly, we had to determine the location of the magnetometer chip inside the phone using the meter sticks and moving the phone along with in respect to a magnet until we were able to get the correct calibration. Secondly, we chose different starting positions for the bar magnet relative to the magnetometer chip and measured the magnetic field from the bar magnet at that position for both on and off axis tests. Then we tracked these magnetic measurements in Excel sheets in order to determine the values that I had spoiled at the start as well. And then third, we changed the distance of the magnet from the magnetometer and repeated the experiment several times in order to get that linearized equation. So this is the observed model for the on-axis data points. I've shown the Excel values to the left. I'm not going to go into any detail though. Importantly, the system is the magnetometer in the phone and the surroundings are the bar magnet. And then also that equation right there that is shown in the Excel sheet is very valuable to us in the calculations shown here. So we use that linearized form of the magnetic field calculation equation in order to find the value of K and also the value of N, which are calculated as such right here. And then using those values, we're able to calculate mu right here, which I showed at the start, which is 1.57 amps meter squared. And then here is our observed model for off-axis. We realized we were supposed to probably use 3 of the same distances for the perpendicular axis, but we just did 3 different ones. But system and surrounding stays the same. For the computational model, we ended up choosing this middle point at 0.15 meters in order to do our calculations. So for the code of the computational model, I've shown the segments of the code that I've changed from the template here, where I inputted a dipole, magnetic dipole formula calculation, and then I've inputted our mu mag and also our d perpendicular distance in order to get the generated results. As can be seen, the results are quite different than what we calculated in the Excel sheet in the slide shown before, but I'll get into why that may be in the next slide. Right, so the potential sources of error, the highest likelihood one is that there are surrounding electric and magnetic objects that skew the data, especially since we're working on a table that ran power lines through the table and we were working right on top of it. There likely was a lot of hindrance from this to the data. Secondly, the exact location of the magnetometer was probably not found. It's very difficult using human calibration to find this. And thirdly, when we were measuring the distance from the magnetometer to the bar magnet in several of our experiments, this value is definitely not exact either because, once again, human error. And then for the further question, for the what if question, well, the magnetic field of the Earth would interfere with the bar magnet's magnetic field, and that would even further skew the data. And then for the what if question, the magnitude of the magnetic field would double and the direction would stay the same. Thank you.